to section 8.3, which is on simple interest. And some of you may have seen simple interest before. Maybe not, but here's some vocabulary. So interest is the dollar amount one pays for borrowing money, or maybe it's the dollar amount that one gets paid for lending the money. Depends on which side of the coin you're on. The principal, we are abbreviating that with a capital P, is the amount of money we deposit or borrow. We might also call that present value. Notice that it also starts with a P. So principal or present value. And then the rate with a lowercase r is the interest expressed as a percent. Okay, so we've got interest, principal, and rate. If you want to find the simple interest for an amount that you either deposit or you borrow, then we have this formula here. So interest equals principal times rate times time, or you can use the variables there. I equals PRT, where R is expressed as a decimal. So even though they give you the rate as a percent, you need to express it as a decimal when putting it into the formula. And T is the time in years. Okay, so how might we apply this formula? Let's say that you have a principal. Let's say that you're borrowing $7,000. You have a principal of $7,000 at a rate of 5% for 1 year. So we can calculate the amount of simple interest that this would accumulate using this formula. And so notice that R has to be expressed as a decimal. So if we have a rate of 5%, how would I express that as a decimal? 0.05, hence why we had to practice doing all of that in section 8.1. Okay, so that was the purpose of going through all those decimals and percentages and so on. All right, so substituting it into the formula, we would find our interest by taking 7,000 times 0.05 times 1 year, okay? Because remember, time is in years, so it was 1 year, so times 1. So multiply 7,000 times 0.05 times 1. And what do you guys get? 350, good. And note that this is about money, so we want to show our unit. So $350 is the amount of interest that would accumulate over 1 year if it was using simple interest for this amount at this rate. Okay, so that's what that means. So let's say that you were the borrower, okay? You borrowed $7,000 at a rate of 5% for just 1 year. Then you would not only have to pay back the $7,000, but you would have to pay $350 extra in interest. So let's go ahead and do that again. So using the same formula, here, for those of you that just walked in, I'll leave the formula up at the top there. Using the same formula, do this problem. The principal is $260 for 4% for a time of 3 years. Okay, so substituting in, we have 260 for our principal. Our rate is what as a decimal? Careful, I heard 0.4, but 0.04, good. You could have 0.04, okay, but yeah, just make sure that you're moving that decimal 2 places to the left. And then times the time, which is 3 this time. Okay, so multiplying this out, what did you guys get? Here, somebody raise their hand because it's hard for me to hear. Yes. $31.20. Does everybody agree? Okay, and in your calculator, you probably got this, right? 31.2, but very good to denote that it is money. So we need to make sure that we list out 2 decimal places for our cents, $31.20. Okay, any questions so far? Hopefully this is somewhat straightforward. All right, so now this one gives us a little bit of a difference. We have a principal of 18,000, a rate of 7.5%. This time our time is 18 months. Okay, so first go ahead and convert the rate to a decimal. And so what do we get there? Good, 0.075. Because even though you have 2 digits there, you still have to move your decimal place 2 places to the left, giving you a 0 in there. So 0.075. Now, remember I said that the time had to be in years? And this time they gave you the time in months. Okay, so consider the fact, how many months are in a year? 12. All right, so we have to do a little bit of converting here. So even though it says the time is in 18 months, how do we figure out how many years this is? Okay, so, but what did you do in your head, sort of? So, 1.5, but how do you get 1.5? You did it, but 12 months in a year, but what operation was your brain doing? Division. You divided, you just didn't see it that way because you're saying 12 months and then I still have 6 left over, right? You took out that 12 goes in one time for 1 year and you had the 6 left over. Okay, so you need to divide by that number of months in the year. Okay, so again, you can leave it in the form of fraction. You can change it to a decimal. However, if your decimal is not a terminating decimal, then you can't use a decimal value. It will go on forever, and if you round it, you will not get an exact answer. So be careful if you're using your calculator to get a decimal answer. Now, this one does give you a terminating decimal of 1.5. So terminating decimal means that it actually ends. It terminates. But sometimes you might get like a 1.33333333. If that's the case, you need to leave your answer as a fraction. Because notice, and you could even leave it as 18 over 12 because you're going to use your calculator to do all of the calculations anyway. So however you feel comfortable doing that. But plugging it in, we've got 18,000 times 0.75 times 1.5 because that's how many years it is. 2025 is what I got as well. Yeah, how would you deal with it when it's a repeating decimal? Yeah, I was actually going to go ahead and do this problem just using the fraction and not reducing, so you can just see what you would do even if it's even if it's terminating or repeating. So working this problem again, this is really equivalent to 18,000 times 0.075 times 18 over 12. I could reduce that. I could reduce the 18 over 12, but I don't need to because I'm using my calculator anyway. And so you're actually going to type it in just as you see it. 18,000 times 0.075 times the numerator, and then the fraction bar really means division, right? So times the numerator divided by the denominator. And so let me go ahead and show you on my graphing calculator on the computer. Okay, so typing in this problem here, I would have 18,000 times 0.075 times the numerator of the fraction, 18, and then just divide by the denominator, 12, and then hit equals. Okay, it knows order of operations as you're typing it in correctly. And so see that you get the same exact answer, 2025. Okay, so if, again, if you got a fraction, let's say it was, you said 20 over 12, right, was your repeating decimal. So let's say it was 20 months instead of 18, you would get 1.66666 repeating. And so if you typed a 1.67 even, you won't get the same answer necessarily. So you need to put it in with the exact fraction. And here's a little trick, by the way. If you mistype something in a graphing calculator, you can hit second. Oh, actually, that's going to bring me back to this. Sorry, it won't bring me back to my original. I waited too long. Okay, so I can put 18,000. I was hoping not to retype the whole thing, but I had a step in between. Times 0.75 times 20 months divided by 12. Okay, give me 2250. Now let's say that I change that to that repeating decimal rounded. Okay, so see how I did second entry and it just retyped everything? Now I can go back and delete this portion. If I were to put 1.7 here instead, I don't get the same answer. So even though it rounds to 1.7, it is not the exact fraction of what we had. So it's so important to make sure that you're using the exact values, because notice that that gives me more interest to pay. I don't want to pay more interest. I want to pay exactly what I'm supposed to be paying. Okay? All right, so let's take a look at another problem here. 12,600 is the principal this time. The rate is 9%. And this time the time is 60 days. Okay, so last time we divided by 12 because there were 12 months in a year. How many days are in a year? 365. However, we're not going to use 365 because there is something called the banker's rule. And in banking, they use 360 for the number of days in a year. Now, this is because they've been doing simple interest and compound interest and all of this since before we had calculators and computers. And so because it was more difficult to do this by hand, it was just a banker's rule. It was okay to just use 360 to make it easier for the division. Okay, so, and in your homework, it usually says, use 360 days in a year. So the banker's rule is that there are 360 days in a year, even though that's not actually true. There's really not exactly 365 days in a year either, are there? Because what happens every 4 years? Leap year, okay, and we add another day in there. There's really 365 and a quarter days in a year. And so it really, it's like, at some point, it's not ever going to be exact anyway. So, all right, so to change this to the amount of years that this is in years, we're going to take our 60 and we're going to divide by 360. Notice, again, you can type in this fraction as is, but notice that there are zeros at the end. We could go ahead and just cancel out a 0. That would make that fraction a little bit easier. And this is the same as 6 over 36. 6 over 36 gives you a repeating decimal. So this is not one that you want to change to a decimal. You can leave it as 6 over 36. If you're really good at reducing fractions, you can even reduce that further. Notice that 6 goes into 6 one time and 6 goes into 36 how many times? 6 times. So this is also equal to 1/6 if it's just easier to type a 1/6. Again, you can leave it as 60 over 360, or you can leave it as 6 over 36, because your calculator is going to recognize it all the same. It's up to you. So putting it into your formula, we've got 12,600 times, what's my rate as a decimal? Okay, 0.09. And then I'm going to go ahead and put in 1/6 since we've already reduced this. Okay, so hopefully you started out with 12,600. Whoops, too many zeros. Okay, 12,600 times 0.09, and then times the numerator, times 1, divided by 6. Now, I didn't really have to do a times 1 because times 1 doesn't change it, but just to get you in the habit of saying times the numerator divided by the denominator, and we get 189. Did everybody get 189? Okay, good. All right, so our interest is $189. All right, so simple interest is used for a lot of short-term loans, like maybe car loans. They're short-term. They're only, 3 to 5 years. It could be just a simple short-term business loan. It could be probably simple interest is what's used when it's like a personal friend. If someone you know is just lending you money out of their pocket, most likely they're going to use simple interest, if they're going to charge you interest on the loan. So let's look at it from a different perspective now. So going back to that original example, remember we did this one, 7,000, 5% over one question? Well, even a simple calculator can do what I just did. So if it's just a 4-function calculator, that's what we call the calculators that have plus, minus, division, and multiplication. If it's just a 4-function calculator, you can still type it in just like that. You can do, this times this times this divided by that. Or you can say, 7,000 times 0.05, hit equals. Take your total and then say that amount times the number of years and hit equals, depending on what your calculator does. But what we're doing today, your simple calculator can do. I'm glad you brought up the whole calculator thing, because what we'll do in like the 5th and 6th section, much more complicated, and that's why in the beginning of the semester I said you don't have to have a graphing calculator. It'll help for Chapter 8, but if you have a scientific calculator like this one, this is actually the one I've been using here at my desk. This is a $12 calculator that has $15 maybe, depending on where you're at, that has parentheses and this little exponent key that looks like this. Then this will do what the graphing calculator needs to do in this chapter. Okay, so again, this a 4-function calc, you can still do what we're going to do. It's going to get very difficult, though, in the later part of this chapter to use a simple calculator on these big formulas that we're going to get to. So if you can invest in, $12 to $15 calculator at Walmart, that would be very helpful. Okay, so going back to this problem where we got an answer of $350, right? So let's say the question was this. How much money would you have in the bank if you deposit $7,000 into an account that gives you 5% interest for 1 year? So based on our previous answer, we got the interest was $350. Okay, we already worked that one out. So say that a little louder. So you would have $7,350 because you put the $7,000 in, right? And then once the interest accumulates after that year, then the bank will put that $350 in. And so you just add it. So this is called your future value. And we're going to label that with a capital A, your future value. What do you have after you've accumulated all of this? And so your future value is when you just take your principal plus your interest. So in this case, we had $7,000 plus $350, which gave us $7,350. Now this was based on the fact that we had already worked out the interest. We had already done that part of the problem. So we just had to add that amount to the principal. Let's say that you haven't worked out the interest yet. Well, then you could do all of this all in one step if you take a look at how the formula works. So notice how we have principal plus interest. And we know that our formula for interest, so let's look at this formula down here. Okay, so A equals P plus I. We know that interest is the same as principal times rate times time, right? So if I do a little algebra and I substitute this in for the I, because what if I haven't found what I is yet? Then I have a new formula that looks like this. Plus PRT. Now this is not what the one in the book looks like yet, because what they went ahead and did, notice that both of these terms have a P in it. Okay, again, a little bit of algebra. If you factor out the P, then this is what you have left. So factor out the P, and so divide each term by P. P divided by P is 1. Factor out the P here, and you're left with RT. And so here is your formula for future value using simple interest. And this is how we derive formulas. We look at what we already know, we put it in there, and we manipulate it to give us something new. So if you only want to know what the future value is, it didn't ask you to find the interest first, then you can go straight to this formula and just put it in, and then the answer will give you that total amount. So let's work it out again. We've got $7,000 at an interest of 5% or 0.05, and the time was 1 year. So substituting in what we have, we've got 7,000 parentheses 1 plus 0.05 times 1 year. So everybody okay where I substituted the values in? P is my principal, R is my rate as a decimal, and T is my time. So if you don't have parentheses on your calculator, then you have to do the order of operations for your calculator. So order of operations says we have to do what's inside of parentheses first, and then multiplication comes before addition. So 0.05 times 1 is really just 0.05, right? And then add that to the 1. So we have 7,000 times 1.05, because that's what you get when you say 1 plus 0.05. And then multiply those numbers together. Okay? And so hopefully you get 7,350. You get it all in one shot. So you get an answer of $7,350. That is your future value. You didn't have to do the interest formula first and then go ahead and add it to your principal. You just do it all in one formula. Now let's say you do have parentheses. Then you can just type this in all in one step. Now again, you guys know that you're showing me work on a test if it's not multiple choice. So your work would be to at least write down what your formula is with your numbers substitute in there, right? You write that all out, and then you use your calculator to show what you get. So, well, it's more basic than compound interest. So the simple interest is only interest on that time period. We are actually going to talk about compound interest next class, and so you'll see the difference between that. So now putting this in, we've got 7,000, and then parentheses, 1 plus 0.05. I can use parentheses, or I can just say times 1. I don't have to use that extra parentheses that I wrote in the problem. That just signified multiplication. So 1 plus 0.05 times 1, close your parentheses, and then hit enter. So you can type, whoops, not 0. Hold on. Let me try this again. Okay, so 7,000 parentheses 1 plus 0.05 times 1. Of course, the 1 is redundant, but I'm just showing you that because what if it's not 1 year? It could be 2 years times whatever the years are. And I don't know why it keeps typing a 0 in. So I wonder if my board is not aligned. I think that could be what the problem is. But if you hit enter, it should give you $7,350. All right, so I'm going to have you work on a problem on the other screen. While you're doing that, I'm going to align my board so that it will work. Okay, so if you're, for the recording purposes, the recording can't see the problem yet because it's on the other screen. Okay, so the problem calls for a principal of $6,000, a rate of 4.5%, and a time of 9 months. And we want to find the future value. So we're using this new formula now for future value. A equals P parentheses 1 plus RT. But what do you notice about this problem? 9 months. Okay, so we have to make sure that we're representing our time in years. So what are we going to do to this 9? Okay, Bill, how did you get that? What are you going to do to it? Divide it by 12. Good. So 9 divided by 12. And you can leave it as a fraction, or this one came out to a terminating decimal. It came out to 0.75, so you can use either value, whatever one you want. And then your rate as a decimal is 0.045. Okay, so substituting in your values, you have 6,000, parentheses, 1 plus 0.045 times, you can either put 0.75 or you can put the 9 over 12. We've got 6,000 times 1 plus 0.045 times 0.75, close your parentheses, and did everybody get 6202.5? Okay, good. Now, this is money, remember, so you should have a dollar sign, 6202 point what? 50, good, 50. Now, let's say I had done the fraction instead, so let me do second entry and retype this. Okay, so if I was going to leave the 9/12 as a fraction, even if I leave it and I don't reduce it, you got 0.045 times the numerator 9 divided by the denominator 12, and then close your parentheses, and then you get the same answer. Okay, so even if it's a fraction or a decimal, however you type that in will give you that same answer. Okay, so there's your future value given the principal, the rate, and the time. Now, what if you know what the principal is and you know what the future amount is, but you're wondering what rate they're charging you? Like maybe a bank will say, okay, I'll loan you this much now, but you're going to owe me this much after. They didn't tell you what the rate is. And you're curious, what's the rate that they are charging you the interest at? Okay, so to find the simple interest rate, given the principal and the future amount and the time. So in other words, you're going to borrow $3,000, but you're going to have to owe the bank after a year $3,180. You give me $3,180 at the end of the year, and then it'll be taken care of. Notice that you have an A in your problem. Because you have a capital A in your problem, well, then that means you have to use this formula, because the other formula doesn't have an A in it, right? The I equals PRT. It doesn't have an A in there. Now, you could figure out what the interest is and then use that formula, but it would be easier to just go straight to this formula right here. We're going to substitute in what we know. So for the future value, we put 3180 over here. The principal is 3,000, so we're going to put that there. And then we've got 1 plus, we don't know the rate, and we're going to multiply that times 1 for the time. Now, usually there's more than one way to work out a problem, and just like there is in this one, I could simplify this at least. So instead of having r times 1, this is 1 plus r, right? Because r times 1 is r. Now, in order to solve this problem, we have to get r by itself. So there is a little bit of algebra in this class, okay? We need, and there's more than one way to do this. What most of my students typically do is they want to get rid of the parentheses. And how can we get rid of the parentheses? Distribute, yeah. So we can go ahead and distribute that 3,000. And we have 3180 equals 3,000 times 1 is 3,000, plus 3,000 times r is 3,000 r. So now what do we have to do to get r by itself? Okay, subtract the 3,000 that doesn't have the r in it. Anything that doesn't have an r in it goes to the other side. So that gives you 180 equals 3,000 r. And now divide, right? So because we're multiplying 3,000 times r, the opposite would be to divide 3,000. So in your calculator, 180 divided by 3,000, 0.06, good. So my calculator has 0.06. Again, that's the same as 0.06. Now this is your rate as a decimal. But when you're typing in your answer into My Math Lab, it's going to ask you to put in a %. So now what do we have to do to this? Move the decimal 2 to the right And so that gives us 6% as our rate. Okay, so you're going to type in a 6 as your answer. Again, part of why you had to practice all of that in section 8.1. Hopefully you guys that were rusty, you did your homework over the weekend so that it feels more familiar. All right, go ahead and do that again. Find the simple interest rate given this information here. You got a principal of $10,000, future value of $14,060, and a time of 2 years. You could say future value. You can also say future amount, where that A comes from. Go ahead and work with the person next to you. Okay, so let's see how you did. Using that formula, A equals P times 1 plus RT. You put 14,060 for A, hopefully, and 10,000 for P, and then 1 plus R times 2. Good. All right, so let's just clean that up. So we have 1 plus, instead of R times 2, it's really 2R, right? That's how we typically see that, okay? If you didn't rewrite it like that, that's okay. If you like sort of rewrote it when you distributed. So, what'd you do first? Distribute. And there are other strategies if some of you chose to work it out differently. That is fine, because you're going to show me your work. So we've got 10,000 times 1 is 10,000. 10,000 times 2? 20,000 R. Okay, and so now what? Subtract the 10,000, good. And that gives us 4060 equals 20,000 R. And now divide by the 20,000. Okay, did everybody get 0.203 for R? Okay, so most likely it'll say round to the nearest tenth of a percent. We talked about this last time, but I just want to reiterate that if it says this does not mean round now, because we're still in decimal format. It wants it to the nearest tenth of a percent. So we need to first change it to a percent, which means move your decimal over 2 places. And so then we've got 20.3% equals R. Are we already, notice that we only have a tenth, right? 0.3 is our tenths. And because we're already at the decimal place that we want, then there is no rounding necessary. We're going to leave it as 20.3%. But it's still going to say those instructions. So I don't want you to get thrown off just because it told you to round. Doesn't necessarily mean you need to round in the answer. Okay, so I've got a handout with a couple examples on it. So I'm going to give you guys each the handout and then just have you work with a partner to work on these 2 problems. One of them is, we've already worked through both of these types of problems. So the first one says, in order to start a small business, a student takes out a simple interest loan for $5,000 for 3 months at a rate of 12.25%. You need to figure out how much interest must the student pay and then find the future value of the loan. So the second problem says, to borrow money, you pawn your guitar. Based on the value of the guitar, the pawnbroker loans you $600. 1 month later, you get the guitar back by paying the pawnbroker $1,270. What annual interest rate did you pay? So this is just like the last problem we were doing. Number 2 is basically finding that missing rate. Okay, let's see how far you guys got. So if you were going to find part A of the first problem, which formula did you need to use? Yeah, the I equals PRT. You're just looking for interest, and you know it's simple interest. So I equals PRT. And so P is the 5,000. Okay, the R as a decimal, .1225, is that what everybody used as your decimal, .1225? And then your time was 3 months. So what do you have to do to that 3? Put it over 12, good. So we got 3 over 12 years. So substituting in, we get I equals 5,000 times .1225 times 3 over 12. Okay, so using the calculator, I've got 5,000 times .1225 times the numerator 3 divided by the denominator 12. And we get 153.125. Okay, so this one not only has an application, but now it helps us to practice our rounding. Because sometimes you guys do all the hard parts right, and then you get to the rounding and you screw up the rounding and you get the whole problem wrong. So let's make sure that that doesn't happen. It wants us to round to the nearest cent. How many decimal places is that? 2. Okay, so we're rounding to this spot right here, but you always have to look to the next number to the right. So this is going to round to what? 13. Right, it'll be 13 cents because if the number to the right is a 5 or bigger, then this number goes up. If this had been less than 5, if it was .123, then you would have left that digit at a 2. So it either stays the same or it goes up 1 when you're rounding to the nearest cent. Now, I'm pointing this out for a reason because in the next formula I give you in the next examples, it's going to round differently. So you need to pay attention that says round to the nearest cent. So we have 153.13 for that first answer. So since we've already found the interest, how can we figure out what our future value is now? Add that, to the, which part? The original, right, the original loan of 5,000. So to find our future value, all we have to do is take our principal and add the interest with the rounded amount already. And so that gives you $5,153.13. Okay, any questions on that first problem? So now for the second problem. So you pawn a guitar. So based on the value of the guitar, the pawnbroker loans you $600. 1 month later, you get the guitar back by paying the pawnbroker $1,270. What's the annual rate, interest rate that you paid? All right, so what information did they give you as far as, okay, if this is our formula, what values, what numbers stand for what letters? So one what? 1/12. Okay, because you had 1 month. Okay, so the time was 1 month, and so you said 1/12 stands for T. Good, because we want it in years. Okay, what else did we have in here? Okay, so 1,270, which was which value? The A, good. So that's your future amount, what you have to pay in the future. So that's your A. And then one other value that you were given, the principal is P, so 600. So plugging in what we have, we've got 1,270 for A, 600 for P, 1 plus R times 1/12, which is really the same as 1/12 R. So however you wrote it is fine. Okay, so now when you distribute, you get 600 times 1 is 600. And what is 1/12 of 50? Even? Okay. So, and you just did 600 times 1 divided by 12, if that makes it easier for you guys to do that in your calculator. And so you get 50R. All right, so now subtract the 600, and you have 670 equals 50R. Divide by 50. And you have a decimal value of 13.4. Is this what your final answer is? No, because this is even though it looks like a percent, it's a big number, 13.4, you still have to move your decimal 2 places to the right. And so you get 1340%. It's a huge percent. You paid more than double what they gave you. Okay? It's more than double, so it's more than 100%. Okay, so don't be thrown off by the numbers. You still need to follow that pattern. Now, the other thing that they might ask you, say you're preparing for the future. Say you know what you want to have saved. This is usually why we use this type of formula. You know you want to save a certain amount. You don't know what you need to have now. Like, what do you need to put into that account to save for that future amount? So this is called looking for your present value, or your P. Remember I said principal could also be called present value? So find the present value. If the future amount you want is $8,500, you can get some kind of special savings account at 7% for 3 years. Maybe it's a CD or something special that you can save with simple interest. Okay, so notice that you have an A that you were given. So that's your heads up to say, oh, well, the formula that I had with an A looks like this. Okay, the formula that I had with an A looks like this. Now, we're not trying to solve for A, we're trying to solve for P. Maybe it would be easier if I just went ahead and did that to the formula now. Like, right now, P is being multiplied by this parentheses. In order to get P by itself, I have to do the opposite of multiplying by this parentheses. So what's the opposite of multiplying? Divide. If I divide by this entire parentheses, if I divide it to one side to cancel it out, that means I have to divide it to both sides. And notice now I have a new formula. P equals, A is in my numerator, and 1 plus RT is in the denominator. I might encourage you to leave the parentheses in the denominator because you're going to need to type parentheses if you have a calculator with parentheses in there. And so this is called your present value formula. For simple interest. So now I can substitute what I know. First of all, I need my rate as a decimal. So what's my rate as a decimal? 0.07. So now I have 8,500 over 1 plus 0.07 times 3. Or I could have done a little multiplication symbol there instead of a parentheses. Now, if you don't have a calculator with parentheses, then what you're going to need to do first is the denominator. You need to go ahead and multiply and add by 1 and get what your denominator's value is. If it ends up being a very long decimal, you need to write a whole bunch of, like, don't round too early. Write as many decimals as you can, and then do the division. If you have a calculator with parentheses like mine, then we can just type it in as we see it here. So we had 8,500 in our numerator, so 8,500 divided by, and now I do my parentheses. 1 plus, what was it, 0.07? And you can either do another set of parentheses or you can just say times 3 and close your parentheses. But if you wanted to, you could write it like this. You could do parentheses 3, but then you'll need a double parentheses, just like I wrote it on the paper there. However you do that is fine. It's going to give you the same answer. And notice we get 7024 .793388 and so on. Now again, if you don't have a calculator of parentheses, you have to do the denominator first, where you say 0.07 times 3, then add the 1, and you get 1.21. Then put that as your new denominator, and you have 8,500 divided by 1.21, and you get the same amount. So you can either type it all in at one time. Now, if the denominator comes out to a repeating decimal, it would be much handier to type it all in at one time if you have parentheses, okay? Because then it'll just keep it as that most exact answer. All right, now, when it comes to present value, the instructions are always going to ask you to round up to the nearest tenth. Okay, round up to the nearest tenth. I'm sorry, not tenth. Sorry, to the nearest cent, because we're in money. Round up to the nearest cent. Notice that this additional word was in here, round up. Now, the reason why they're asking to always round up for present value is because if I round to the nearest penny now, and I put in 0.79, notice how there's extra pennies that were in there? If I use that amount, I will not quite reach 8,500. I will be a little short of my goal. So it's better to be a little bit over your goal than to be short of your goal. So you always want to round up to the nearest cent. So if that's the case, when you look at the penny, the 9, if there is any amount after the 9, then you're going to go up to the next value. So you can look at this as, instead of a 9, as 79. If you go up from 79, what do you get? 80. And so rounding up to the next, to the nearest cent would be $7,024.80. The only time that you would not actually move that value up is if in your calculator it came out to exactly 0.79 and nothing comes after that. And then you would just take the actual value that you have in your calculator. Okay, so go ahead and do that present value formula again. This time, the time's going to be in months. All right, guys, so future or present value. Hopefully you put 2,000 in your numerator. And then you've got 1 plus 0.126 times 8 months. So how did I have to write this in here? 8 divided by 12. Good. Close your parentheses. And so if you're putting this in all at once, we've got 2,000 divided by parentheses 1 plus 0.126 times the numerator 8 divided by the denominator 12, and then close your parentheses. And did everybody get 1845.01845? Okay, so if you are rounding up to the nearest cent, what should you have rounded to? 2, good. So 1845 and 2 cents. Okay, so that finishes out section 8.3. That's what you have for homework.